Welcome everyone to the 981st monthly meeting of the Amateur Telescope Makers of Boston. So, Happy New Year. So I just want to recognize the events of the Southern California. I think some of our friends and people we do not know are affected, so I'll talk with them. Now, just to start, I just want to say that one of the first books that I had come across when I went into astronomy is this book, Turn Left at Orion, right? So the author of the book is Dan Davis. He had come and visited us today, so he's sitting in the corner there. Diana, thanks for the introduction. So hopefully he'll be giving us a talk. I want to bring up another topic, which is we have a lot more speakers than the slots that we have. So since we are usually using our monthly meetings as the speaker slot, I was thinking maybe people will be people will be interested if we can have a Zoom meeting every 2 weeks or so, if we can fill up those slots. So we can talk about that. So that's an opportunity to learn from a lot of other people. So Rich and Glenn.
All right.
How you doing?
Come on, Glenn.
There's always a lot of living this time.
I'm so
Do you, maybe you need to use this. Rich, can you use this?
We can if you want.
Yeah, those two are
Yeah,
fine.
they're loud enough.
You all can hear me, right?
They were teachers.
I'll turn up the volume on my teacher voice.
I'm sorry, what?
You want to start?
The
Go
teacher
ahead.
voice, by the way, is when in September you get hoarse the first day of school because you haven't been talking all summer long. Go ahead, you lead off.
Well, this is a famous quote by Carl Sagan, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." And I thought this was a good saying to put up there to remind us all of where we come from and where we're all headed, because one of our dear friends in the Rhode Island Club recently passed away. We want to just make mention of that. So you can click the next slide, you know how to work the slide.
Before you do, I did want to jump in on that. We'll go back just
Go
a
back.
second. I get my
Clicker.
teacher voice is back already.
Then who's got the clicker?
Oh, okay, we're good to go then. All right, because I didn't even know how to. Yeah, anything with technology, as you know, the year I was president, I couldn't even turn these lights on and off. So better if somebody else does the clicker. Yeah, this was a good thing talking to kids because especially when they're in their teens and middle age or middle school age, they have a lot of doubts about their self-worth, their self-value. So I do that whole thing about the iron in your blood was made by a star that went supernova, and you are literally made of star stuff. So when you look up there, you came from the stars. And the other one, and Sagan said this as well, it's kind of a weird thing. So maybe 5 billion years ago, a star went supernova. Those gases went out, created the solar system, the planet we're on, the iron in your blood, the whole thing. So now, those materials that came from that star, looking out there, why did I blow up? It's actually asking the question of its death. So it's kind of a weird thing to think of, that material came alive. Now we'll go to the next slide.
We recently lost a friend of ours at the Skyscrapers, was Dave Eustace. He would have been 72 this month. A member of that club forever.
Yeah.
Served in most of the board positions. He was the club's most recent librarian and historian. So he'll be missed. He was very active in the Skyscrapers.
How many of you knew Dave?
Yeah, if you go to the conjunction, not the conjunction, the Astro Assembly.
Yeah.
You'd always run into him there, and he'll be missed. We just wanted to take a moment to reflect on Dave, and we'll do the same for you someday. All right, next slide. We're going to jump. I took Glenn's cartoon out, so we're going right into the planet around him.
You'll see it, don't worry.
So if you've been out in the early evening, you've noticed this big bright object in the southwest at sunset, as did many of the folks at the star party on Tuesday night. Venus is spectacularly bright right now. So bright that I'll bet if you try, you might even see it in the daytime. I think you should give that a try because it's really super bright now. Minus 4.4, it's 50% illuminated, 24 arc second apparent diameter. And if you want to try naked eye observations, on February 1st, the moon passes about 2.5 degrees beneath Venus as we see it in the sky. So it's a great opportunity to go out and see if you can see Venus with your unaided eyes in broad daylight. And the moon just is there to help you out. Yes, sir?
You know kind of what time of day they're closest?
It's during the afternoon they're closest. I didn't look that deeply into it, I just know if you can find the moon, most of us have planetarium apps on our phones, that'll really give you a pretty good idea of the orientation at any given moment. That's what I do. I use my Sky Safari every day. I open that thing up 10 times a day just to answer questions and see what's going on. But that's coming up on February 1st. Inferior conjunction for Venus is on March 23rd, and I'll remind you about this next month and at the March meeting. It'll 1% illuminated, it'll still be -4th magnitude. And when it's still that bright, you can still pick it out in the daytime sky. The beautiful part of inferior conjunction is that it is a razor thin crescent. It is the most glorious thing to look at. It's fabulous. You have to do it in the daylight, of course, because it's at inferior conjunction. This time, it'll be 8.5 degrees away from the sun, to the north of the sun. That's 17 solar diameters. It's not even sport. You know, I've told you my record is 1.69 degrees from the limb of the sun with an unfiltered telescope. Yes. Don't do that. That's really dangerous. All right, don't do that without practice. But this is a great way to practice. So that's going to come up in March, and I'm going to remind you of it because it is really such a cool thing to see. All right, next slide. Saturn is setting about 9 o'clock now.
Question?
Yes,
Would you, this is kind of a personal question, but I'll ask it.
go for it.
Would you consider it cheating if somebody uses a go-to
Oh,
telescope?
no, do that.
I wouldn't use a catadioptric though.
Yeah.
I wouldn't use a Schmidt Cassegrain.
Why'd you say that?
It's far away.
The optical axis might not be pointing at the sun, but it's such a short tube and a fast mirror that the reflected.
Right, it's like
You'll give a
a-
lot of glare. You'll give a lot of glare. You know, when it's really close to, when Venus is really close to the sun, I have two ways to shield the sun from the optics. Because I typically use a reflector, and it is not uncommon when it's, let's say, 3 degrees from the sun or 5 degrees from the sun, you've got quite a bit of sunlight falling down into that telescope tube. And that produces a lot of glare, especially when it hits the main mirror. So there are two ways that I know to get around that. First of all, you can build a dew shield for your telescope. I've actually constructed a long shade because it's a tangent function. And as the elongation goes to 0 degrees, the sun shield has to be infinitely tall to cast a shadow onto the telescope. So there are limits here. You can also use an off-axis mask and then shield that, just to keep as much sunlight out of the telescope as possible. Be careful using the off-axis mask because you can actually burn the mask from the inside out. You've got to be careful of that.
So what I do when I've looked at Venus is, I don't see anything past the north-south line. So I wait for the sun to go past that line, so I have the shadow of my house on the telescope.
Sure,
There's no way anything is gonna happen, right?
that's a great way to do it. Just be careful.
The sun's not hitting the telescope.
I've had a finder scope light on fire before.
Really?
It's actually pretty cool.
No, actually, it's very hot.
Yeah,
The kind of thing you do just once.
that's it. Like, telescopes will burn to the ground. Now, you can burn a telescope to the ground. I've seen pictures of telescopes, dogs mostly, that have been left outside. Phil, wait, where's Phil? Did you have a telescope one time that was smoking out in the observing field?
It was out,
You know, that's bad for your health, you know. So.
not with mine, but somebody had sold me, they had a Dobsonian, there was flames coming out of it.
Yeah, oh yeah, they're largely plastic and wood. They'll burn to the ground. So be careful, if you're gonna be playing with the sun, near the sun, with an unfiltered telescope, you really have to be super careful. Be very, very careful. If it scares you, don't do it. But this is a nice one to practice at because 17 solar diameters away from the sun gives you plenty of space between Venus and the sun. This is a pretty easy one to do. Anyway, let's move on. Mercury, don't even try. It's very low in the southeast. At sunrise, pretty much unobservable from the northern hemisphere. Saturn's setting around 9 o'clock. Rings are only tilted about 4 degrees. The folks at the Star Party on Tuesday were impressed that even with my little tiny image in the Dobsonian, you could see 2 lines sticking out from the edge of the planet, the rings. I'm explaining to them that this is a rare occasion to see the rings almost edge on. there's a ring plane passage in March, but the Saturn will only be about 10 degrees away from the sun and unobservable. Way next fall, there'll be a very tight, less than a degree, I think. And that'll be kind of a fun time to look at it. When we're looking at the rings edge on, what you're also able to see from time to time are shadow transits. And in 2025, there are quite a few Titan shadow transits on Venus. A lot of them occur in the daytime for us, but that shouldn't stop you from finding it, right? So we'll talk more about that later. Neptune is still up there, just south of the Pisces circlet. Uranus is sort of near the Pleiades, and Jupiter is at magnitude minus 2.7, 46-inch apparent diameter. It's Jupiter season. I hope you've been out there observing it. The red spot is a little bit faint, a little bit small this year. I use an 80A filter. It's light blue to enhance contrast, and you can see it pretty well. Uses as much magnification as the night will allow. And you can use your planetary maps, and also you can look at my handout that I send out every month on when the Great Red Spot is transiting the central meridian of Jupiter, also the shadow transits. So next slide, please. And again, I'll remind you, there was another opportunity. I sent out a nice email on Tuesday about looking at and comparing Callisto and Ganymede. And at the star party, I didn't mention it to people, but I took a look through Chris's C11, and I could definitely tell which one of these, which was which, because Callisto has an albedo or reflectivity of only about 20%. It's really dark. So you can look at the moons of Jupiter, especially now at opposition, if you can crank up the magnification and see them as disks, you can actually tell, I know, there's big old Ganymede, there's big old Callisto because it's dark. Io's kind of a yellowish color, and the other one's got to be Europa, right?
Yeah, they're all different.
They're all different, and you can see that with your telescopes. You just have to go out and brave the cold. But I just wanted to put that up there to remind you of that. Next slide, please. Then I was texting on his phone. So as great as it is to go out and look at Jupiter, now is the time to go out and look at Mars, because Mars reaches opposition next week. It's actually closest to the Earth on the 12th. Opposition is on the 15th. Now this is not a very favorable opposition. It's pretty far away, it's 60 million miles. It presents itself only as a 14.6 arc-second disk. That's still big enough. Again, use as much magnification as you can, as your telescope will handle, and as the night will offer you the opportunity. But what you want to do is you want to look at some of the features on the planet. The North Polar Cap is visible, but some of the surface features, the dark features that you can see in this picture, and this is set for now. This is right now. That's what Mars looks like in a telescope right this second. If you want to see those surface features, they're very subtle. You have to help yourself out with filters. I like to use an orange filter. A red filter will help also, but I find red filters too dark. And I happen to own a Bader semi-apo filter, which is a really good Mars filter also. Again, the challenge is to see if you can spot the moons of Mars. And again, you need magnification. This says large aperture eyepiece with a occulting bar. I took a 12.5 millimeter orthoscopic eyepiece from University Optics, and I took a piece of aluminum foil and just taped it across the field stop, and that's a pretty good occulting bar. So I can hide Mars behind that and see if I can see the moons. Deimos is actually easier to see, despite the fact that it's fainter, because it ventures farther away from the planet. Phobos is usually lost in the glare of the planet, very challenging.
What does semi-apo mean? What kind of filter is that?
Well, it's a semi-apo filter.
What does that mean?
It means it'll take a refractor, an achromat, and turn it almost into an abochromat. So the way they've got the filtering set up on the way they layered the substrates, it cleans up that chromatic aberration that you sometimes see with an achromat.
What color is it?
That's a good question. I don't know.
That's what I mean.
When I look at it, it looks blue.
Violet.
Looks blue.
The bar gets rid of the blue, but that's
Yeah.
Cutting out the blue.
highest dispersion is blue.
Yeah,
Thank you,
it's kind of a special filter to have.
Never saw
I
that.
bought it for an achromat that was showing all the color.
That's why.
It helps.
Why it looks quite bluish.
Yeah, and when I put it on the achromat, it actually gives things that sort of a yellowish cast.
Yeah, that makes sense.
Yep.
I
So anyway, that's Mars. Do it now, because the Earth is moving pretty fast. It won't stick around for long.
Has anybody actually visually seen those moons in this room?
I've seen Deimos before.
Oh, yeah, okay.
I've never seen Phobos. Bucket list.
Phobos is real close.
It's really close to the planet.
Okay, so you've seen it.
I have.
That's pretty impressive.
Thank you. We try, we practice, we try. That's all. Some good nights, some bad nights. All right, next slide. So, while you're out looking at Mars, might as well set up and look at this, because Monday night, Mars is going to be occulted by the moon. And it favors North America. The Mars will disappear at approximately 9:25 p.m. Come back from behind the moon at about 10:41. Remember, I put the times there, not to the nearest second, of course, because your location determines when the occultation will happen, right? And so your planetarium program will tell you to the second when it will start and end.
Yeah, see, that's why I asked about the moon and Venus, because the moon moves its own diameter in an hour.
Right, oh, right. Yeah, of course of the day, that on the February 1st, the moon will pass beneath Venus, and the orientation will change. Because, as you said, the moon's orbital motion carries it about approximately 1 lunar diameter per hour from the west to the east. But that's going to come up on Monday night. Should be pretty cool to watch. So, there you go. All right, next slide.
Question.
Yes.
Should we use any specific filters to have a better viewing for this? Because I bet the moon will be pretty bright.
The moon will be very bright.
So, I mean,
But Mars is also pretty bright.
yeah, I mean, it is bright as is, but I mean, in order to see it in a better way, or like image in a better way.
A moon filter.
Well, you could use a moon filter, of course.
What size telescope are you using?
I like to let the moonlight just blare into my eyes. Where's Mario when you need him?
Mars has a higher surface brightness than the moon.
A variable polarizer.
That's interesting, right.
One of the things I would suggest, if you have a large aperture telescope,
I have a Mac Cassegrain, or I can use a reflector stop, or
because one thing is you use a moon filter, the other is to just do like an aperture stop, stop it down.
The moon's not all that bright. You'll see Mars.
It is through an 11-inch telescope. If you don't.
Well, the other thing too is I like to, like I said, of course, it depends on your telescope,
Yeah.
and it depends on the seeing conditions on the night, but I would use as much magnification as the night will offer. And you'll be zoomed in, you won't see much of the moon at all. When I look at an occultation, I like to,
like sliver of the moon.
there's only a little bit of the moon in there, and then there's the object that's gonna disappear. At 14.6 arc seconds, it'll take about 30 seconds for the moon to cover the planet up and to uncover it later. The trick will be to see if you can, an hour later, see when can you first see it pop up from behind. You have to sort of know where to look for that.
The moon filters are usually about 13% transmission, which you'll find for a full moon is actually not dark enough. And the way to get a darker filter is with a variable polarizer. And then you can adjust it to the brightness that's comfortable for you.
Yep. I let the moonlight just stream in. Fair enough, fair enough. Glenn brought this asteroid to my attention the other night, and I've yet to observe it yet, but you said that this is a near-Earth object or a hazardous object?
Yeah, the history behind this is one of the things I like to do with that little 3-inch Edmund is notch how many asteroids I can see with that little scope. And I started way back in 1970 with Vesta, and I've been going since then. And of course, what's happened is I've gobbled up all of the brighter asteroids. I think out of the first 50, I've seen probably all but 3 or 4 of them. So the higher the number, the fainter that asteroid usually is. Yes?
Should have done the dim ones first.
Well, with that little, I didn't have the experience of the eye back then. The faintest I've seen now is about 11.2 with that little scope. But this one, I was looking, there is a website that I go to, and I can't think of the name of it, but it has currently the asteroids of the month, so to speak. Anything that's brighter than 11.5, I think. And I saw this one that was in the 9s. And by now I've gobbled up all those 9th and 10th magnitude asteroids. It was a high number, 877. So I did a little research. And it's a near-Earth asteroid. It has a very oval type orbit. So most of the times when it's its opposition, it's way out there and it might be 13th magnitude. But this time around, it's going to be a very close approach. In fact, the next one isn't for another 20 years. I'm not sure I'm going to be around that time. It's 77 now, unless I go out with my walker or whatever. But anyway, it's going to be fairly bright. The only problem is you're fighting the full moon right now. And you just mentioned it's going to be near Castor, right?
Next week. But there's the path through Gemini. It's where it is tonight, is here. And right, this position is where it is right now, up here. And it'll make its way through Gemini over the course of the week. And it's fairly bright, it's relatively close, it's moving relatively quickly across the sky. Of course, using a chart like this to go out and see it might be a challenge. So again, I would offer you to use your, if you have a digital star list, I always carry mine with me. It should pinpoint this asteroid perfectly. And then you can star hop to it and you can check it out. I don't know that you'll see it move in real time, but then if you come out an hour later and reacquire the target, you'll notice that it's moved across the star field.
You know what I did? In fact, this one is moving fairly fast. I did try, and I can't think of the date. It was near the star Bellatrix at that time in Orion. And I do everything visually. If you are an astro imager, you might want to try to take an exposure of maybe 15 minutes. I would encourage you to do that, and we'll show them next time around. I go to the Comet, was it the IAU? I think it's the IAU, whatever the Comet service is, it's here in Cambridge. Would you know, Diane, offhand?
Butterfly Center.
Anyway, I just go to Asteroid Ephemeris, you find it. But anyway, I could also, if anybody wants, email me, and I'll send you, I got the ephemeris day by day. I'm looking at this right here with your Castor. When's full moon this month? Around the 13th or 14th? Yeah. So the moon you might be able to catch this before the moon rises, but that looks like a great opportunity goes by. But if anybody wants the ephemeris, just send me an email. I'll send you out the information on that. I did try it. And again, I do everything visually. What I do is I'll go out and I'll look at the asteroid, and I already know it's there. I'll use a chart, and I'll look for a star that's in the position they say, and I'll make a sketch of the field, and I'll also look at where it's going to be the next night, and I'll make sure there's nothing there. I go by the next night, and if my suspect there's nothing there, and there's something there, I'll call it a notch. And with that little 3-inch, I've already seen about 110 asteroids. This would be my 112 if I can bag the thing. I did go out, and I made the sketch. I came out just, I think it was a half hour later, and already moved a fair amount. And the only problem is my suspect was still there. I sketched the field star that I didn't recognize. I looked at where the asteroid should be, and there was something there, but it was so cold. I figured there'll be this, still it's going to be around for a good chunk of this month, so I figured I'll save it for another night. But it's just fun to look at, just to see, follow an asteroid through the sky. This is a good one to try, because the next time won't be for another 20 years. And if nothing else, try for Vesta. I think Sky and Telescope and Astronomy both will have an asteroid of the month, and there are some that are very easy to see. Vesta can be seen with the naked eye if you know exactly where to look. It's around 5.6 magnitude at its brightest. Okay, any more you want to do on that?
Sure, not on this one.
Okay.
Get out there and look at that. All right, next slide.
By the way, especially you imagers, give that one a shot, because that'd be fun to see that.
So Joseph and I have been chatting recently about this event. So this is Comet Atlas. If you look at spaceweather.com every day, there have been little blurbs about Comet Atlas. It's a comet you'll not hear about on the news, and no one will be showing off giant pictures of it because it's very favorable for southern observers, barely, but really not so for us. It's in the really hugging the horizon in the east, right at sunrise right now. Perihelion occurs on the 13th, and if the comet holds together, it's only, I think its close approach is 0.09 astronomical units. It's about 8 million miles away from the surface of the sun. Pretty hot there. But if it holds together, this is what the scene will look like at noon on Monday, this coming Monday, the 13th. It'll be 5 degrees north of the sun. And my plan is to put the roof of my house right about here, about there, and then go out and see if I can spot it with binoculars. And Joseph's going to work through a skylight, because it's way warmer.
What do they say about
the key is that I've seen Venus a lot, like we've talked about, and this supposedly will be twice as bright as Venus.
I hear like a -6 or 7 even, yeah.
There's at least a chance.
At least a chance. But again, you have to be really careful because it's only 5 degrees away from the sun. And everything we said before still counts for this. So if you're going to try this with binoculars, think about the field of view you've got. You've got to hide that sun pretty good because you're going to be looking in an area of the sky where you shouldn't be. Anyway, we'll report on this next month. We'll see if, you see two guys coming in with white stick and dark glasses, that's us. All right, next slide. The variable star of the month this month, ta-da, a new one, Arla Porus. And the reason I picked on Arla Porus is it's not particularly bright. As a matter of fact, right now, this is the AVSO chart for the last 2 years, and right now, it's down pretty close to 11th magnitude, right? And that's a really, really good time to observe it. Arla Porus is a Mira-like variable star. It's got a period of about 430 days. It's a carbon star. Now, if you've ever been up at the observing site with Joe Henry, he'll always show you carbon stars. He loves carbon stars. So do I. And this is my favorite carbon star. Arla Porus is called Heinz Crimson Star. And if you dig back deeply enough in the newsletters, you'll notice it's also mentioned as Nugent's favorites. I wrote a little article about this about 25 years ago. But what makes it my favorite star is it is intensely red. Most carbon stars look sort of orange, right? They're cool to look at. This guy, especially when it's at its minimum, is red. It is red, like you can't even imagine. The first night I looked at it, I was using a 20-inch telescope. And I had to go into the house and actually bring out a star atlas because I was sure I was on the field, but there was nothing there. It was there. It was so red and so faint I could barely see it. Now that doesn't mean you need a 20-inch to see it. But you will need a finder chart to find it, especially if it's at 11th magnitude. It is the reddest thing you'll probably ever see in your life through a telescope, unless you're looking at the taillight of a car.
So imagine, to find it, if you go in that general area from this chart on the right, there's a little rhombus that basically you can point straight up to where the star is.
Yep. I didn't want to bring too detailed of a chart. It's not as big as that red star, but that's sort of where it is, okay? And I would compel you to go out and look at this, especially when it's near its minimum. It's a great star. It's a beauty. Anyway, that's the variable star of the month. All right, next slide, please.
This is a double star.
Oh wait, there's also a variable star, T Corona Borealis. Remember that one? Remember we talked about this? Anyway, I don't want you to forget about this. Hey, it's coming up pretty early. If you go to bed really late or get up really early, you can pop out and take a look at it.
Right around 2:30.
Yeah, it's in the east at about 2:30 in the morning. All right, next slide. I hear you. Also, anyway, so while you're in Gemini looking at Alina, the double star of the month is Castor. I'm sure we've all looked at it. It's a spectacular double star. It's a multiple star system. It's way more than 2 stars. But the A and the B components are 1.6 and 3.4 magnitude. They're only 5.2 arc seconds apart. And I did double check that this month.
Okay.
The distance is about 51 light years. Again, if you want to practice on things in the daylight, Castor is a great star to look for in the daytime. You can find it with a telescope, right? It doesn't go away. It's just a little harder to find. You have to be able to go find it. But if you search for it, maybe use the azimuth, maybe use your go-to telescope. I've never seen this one in the daytime, but I'm sure it's bright enough to see. And the double star components are said to be quite pretty in the daytime sky. Check it out. Anyway, that's the double star of the month.
This is one I'm going to jump in because I love double stars, as you know. This is a binary system, and back when I first started getting into astronomy in 1970, these two were very close to each other. In fact, I couldn't split it with my little 3-inch telescope. But somewhere around, I think, the mid-1970s, I was able to just barely split them. They're about a little under 2 arc seconds apart. And I even sent an article, a little note on them, up to Sky and Telescope magazine. And I still remember a little blurb there. It says, G. Chappell from Townsend. There was an E.W. Thornycroft from someplace in Switzerland. And I was more excited than if any of the articles I've ever written since. Just to see my name in a magazine is so exciting. But now, this is undoubtedly the finest double star in the northern sky, because they're both very bright. You got a close to first magnitude star. In fact, it is first magnitude. I think the combination, though, it's a little, does it just miss the mark?
I can't remember, but it's pretty.
But it's about 1 point, whatever.
You know it's a bright star.
It's very close. But anyway, this whole system itself, it's a beauty. The only one better would probably be Alpha Centauri in the southern sky. But each of these stars, these two, are binary, they're spectroscopic binaries. So I used to do this with the kids in class. I could So it's got two couples dancing, and they're kind of going around each other like this. The couples are dancing. I can't do much more with my fingers. But there's a red dwarf binary pair that's a little bit outside there. It's about 9th magnitude system. It's something like, I'm going to say 60 arc seconds away, but it's in the field of view. So it's almost like a ballroom dance. You have two couples dancing in the middle, and the little kids are out there dancing around as well. But what I do tell kids at a star party, I'll show them the two and explain there's each of those is a very close binary system. And then I'll show them that other one, and I'll say, when you look at that with the naked eye, you're looking at 6 stars. And they're kind of impressed by that when you tell them that. And I think we can go on now. We've got the observer's challenge at this point.
I think we do.
We'll go to the next slide. Okay, observer's challenge for December. This is NGC 891. It's a 10th magnitude galaxy, and it's not too far from another great double star, Almach, over here, Gamma Andromede. And how many of you have seen this one? I know we got a couple of reports, and we'll show the slides in just a minute. How many have seen it visually? You have the big scope, right? It's kind of a tough challenge. I had a hard time with a 10-inch. I'm going to give it another try, but it's been difficult.
Object? This object?
Oh, I'm sorry, not the double star, the actual galaxy. How many have seen the galaxy?
Yeah, I've seen it, but this is a tough
I've seen
one.
that by 10-inch.
Yeah, it's a tough nut to crack. But anyway, I'm going to show some slides now, and if anybody is either here that took a picture or is online there, we'll let them explain the picture
That's Doug
itself.
Paul's image right there.
And Doug, did you, what are the
Yeah, I'm here. That's about 4 hours. But is that my preliminary?
That might be the preliminary. Let's go, I think we got one later.
The final one should be much larger.
Okay, because what I do is I send the slide deck to Rich, and then sometimes he'll modify, so, but I think you're on after Mario. Is Mario here?
Yes, I am.
Okay,
Actually,
Mario.
I'm 1,000 miles from you.
Good,
Sound very close.
good.
That's, I believe I did red, green, blue, and a little bit of H alpha. So it's about 4 hours because of each of the filters.
Okay, thank you, Mario. Go to the next slide. I think this might be Doug's.
No, I don't know. I'm not so
Oh,
sure.
I see.
Doug, I'll go look for it. I'll put it up. We'll put it on next one. Because
Okay.
I don't think your final one is on here.
Yeah, because I did, when I had the original deck, I had Mario's first, yours was the second one, and then I had Venue. So Rich has rearranged things a little bit.
When Glenn's slides come to me, they look like you took a few sheets of paper and ran it through a shredder. Right? And then my job is to glue all the pieces back together.
Well,
So-
Venue's here.
That is a C11. C11,
So Doug, I'm sorry.
no filters, no guiding, 30 seconds.
What an impressive object, though. You look at
It's an
that.
hour of exposure.
Thank you. Dave, is Dave online or Dave here?
Yeah. Yep,
Yes.
I'm online.
Okay.
So mine was with a C8, an Edge, Celestron C8 Edge. It's about 14 hours over 10 different nights from Carlisle, Mass. So not far from the clubhouse, and it's with a one-shot color ASI 294 cam. So I was able to combine those and get that.
Nicely done. And Rajiv, Maharal, is Rajiv here or online?
Yeah, I'm here as well.
Okay.
Let me see if I can turn on my camera. Yeah, from mine, it's around 31 hours from C11 Edge 8, and I just use UV-IR filter for that. And it's close to Boston area, so Bortle 5.
Thank you. Very nicely done, all of you. I think we have another couple of
I
slides
think
here.
it might be.
Dave Wilbur, okay. Is Dave here by chance?
I'm here.
Okay, go ahead. That's that little C-Star
This was
S50,
a-
right?
Yeah, with my little C-Star 50 millimeter f5. It's nearly an hour of exposure. The elapsed time was closer to 2 hours, I think, on one of these bitterly cold nights when I set the C-Star out in the driveway and came back inside the house and controlled it with my phone, which is a nice thing to be able to do.
And I'm not trying to sell the C-Star. You know I'm a sketcher and a visual observer, and I've always just not had much of an interest in astro imaging, but this Sea Star is amazing. It's under $500. It's a nice entry level, but Phil Harrington wrote a critique of this in Astronomy magazine, and Phil is not a fan of imaging as well, but he was field testing this thing, he loved it, he's got one for himself, and I'm thinking of doing the same thing, picking up one of these things and just doing some simple thing. David sent a picture of the Deerlick galaxy cluster, and he caught those 13th and 14th magnitude galaxies with that little Sea Star S50, so I'm definitely going to plan on picking one of those things up and dabbling a little bit in astro imaging. I'll never be able to do as well as some of you folks are doing, but it'll be fun. It's a new adventure. There's always some chap you can go to. I mean, again, I'm in my late 70s, and I'm like a kid with this thing. So, again, I want to thank all of you that sent in these pictures.
For all the visual observers in the crowd, I will be splashing some cold water on him later.
You know, I still get that little 3-inch Edmund. I'm still looking at double stars I haven't seen and asteroids. So there's always something going on up there, no matter how young or old you are. Yes, we have a question, young man.
Yeah, Glenn, last Friday night, we were using the 25 at the clubhouse, and several of us saw 891 visually.
Yeah.
So it was very impressive. Also, equally impressive is, if you go back to that slide, you'll see there's a very bright field star where everybody uses to find 891. It's in the upper left-hand corner of Dave Wilbur's.
Yeah, okay, because he's got a wide field.
Not there, it's Dave,
The next slide.
Dave Wilbur's side.
Yeah, we have to go forward too.
Go forward, not backward. When you get to Dave, right there.
There we go.
See that bright star in the upper left? It keeps moving.
Well, there's a delay.
Dave Wilbur, 891, upper left-hand corner, there's a bright field star. If you're visually searching for 891, everybody uses that field star. It's 3/4 of a degree from 891. On the opposite side, 3/4 of a degree away, is an Abell cluster. NGC 911, 914, 910, and 890, and others. So it'd be very interesting if somebody could take a picture of that too.
Where is that? Like,
Yep.
from that start?
Yeah, on the other side. In other words, it's outside the frame. But if you would reset the image so that 891 is down where Dave Wilbur's name is, and the bright field star would go in the middle, you'd see the Abell group in the upper left-hand quadrant.
So I missed one. Like,
So we picked out
few weeks
3
ago,
galaxies
I might have
also in that group.
I might have,
Friday
yeah.
night with the 25.
Okay, the January challenge. This is the dinosaur footprint nebula, and it's right near in Perseus, right above Lambda. And I was wondering about this. I said, how do you see a dinosaur's footprint there? But there are 2 nebulas here. This is the imaging nebula, which is about 25 arc minutes across. So almost a moon diameter, a little bit less. It's this bright area here. That's the one the visual observer should be able to see. And it does look like a 3-toed footprint of a dinosaur. So that's where it gets the nickname, the fossil nebula. And it's another challenge. It's around 10th magnitude, and again, spread over an area the size a little bit smaller than a full moon. So it's probably even more challenging than 91 was. And you said you had tried it before and had some difficulty.
I've never seen this. The central area is said to be about 3 by 3 arc minutes.
Yeah.
So that central region is pretty small, so be ready for that. Pink usually tells me I should use a UHC filter on this. An ultra high contrast filter would probably help with this. And dark skies would certainly help.
I did try with the 10-inch and I didn't have any luck. So it was a little bit misty that particular, it was just a couple of evenings ago. There's a little bit of mist in the sky at that time. So I'm going to give it another try. But yeah, it's going to be a challenge for the visual observers.
I've all but given up on emission nebulae from framing.
Yeah.
The sky is just too bright, the stuff just melts into the background. So get out there and give it a shot, and then send your reports to Glenn so he can put them on the newsletter, on the website.
Yeah.
That previous image there was shot with the Canon RA, which is extended red sensitive camera, so that's a good bit of the image now.
So you got a cluster up here and some type of nebula over there as well.
I've always said the deeper we get into these observing challenges, remember Roger had been doing this now for like 13 years.
Yeah.
They become more challenging, right? On a number of nights, I just shake my fist at the sky and go, damn you, Sue French. Because she's picked out most of these, and she lives with, she's probably got magnitude 8 skies, right? So she can see some of these faint things that here near Boston, they are hopeless for us. But that doesn't mean you shouldn't give it a try. You never know. Sometimes you're surprised.
And I
Never
think
know
the
what
next
this
is
guy's
an
doing.
announcement, if the slides are in.
Well, that's it. The next one is the announcement that Glenn and I had a little show at the clubhouse. Next slide, Daniel, please. So this is the introduction of winter sky as opposed to the introduction of the autumn sky. We're going to try and run this on Friday, the 24th of January, with a whole bunch of rain dates from 6 to 8 p.m. at the observing field of the clubhouse.
Yeah, we'll be putting, so we haven't put it out on the website yet, but that will be coming up fairly soon, so you can sign up for this. It'll be the same place, the lower field at the clubhouse, unless we get the type of weather we've been having, where you get a below 0 wind chill. If that's the case, we'll still meet at the lower field, but you're going to have to bring your laptops, because it'll be a Zoom meeting. I'll be inside the clubhouse, and I'll conduct the meeting inside. No, what we probably will do, we'll have a lot of just going back and forth indoors. Well, that's why you only set it for about 2 hours this time, because it's cold this
It's
time of
pretty
year.
cold out there, but that's coming up, so.
We look
so
forward to see you.
Watch for the announcements and watch for, cancellations because of weather, of course. But I think that's the last slide.
That's the last one. So I'm going to leave and just say, keep looking up.
Thank you, Glenn. Nice.
I think I'll introduce our speaker for the night, Nazmus Nasir. The title of the talk is Imaging and Processing the Sun in Hydrogen Alpha. Nazmus is our club member, and he will go over the hardware required to capture images of the Sun in Hydrogen Alpha, along with how to take images and process them to bring out fine details of the solar surface. Nazmus Nasir is a software engineer at Harvard University. Nazmus has been doing astrophotography since 2012 and hydrogen alpha's solar imaging since 2022. He uses a LUN 40 hydrogen alpha telescope, QHY 5-3M mini camera, and a Skywatcher Solar Quest mount for solar imaging. Nazmus also has a YouTube channel with thousands of subscribers, which captures many of his tutorials. So, all to you.
Hey everyone, I am Nazmus Nasir. Many people know me as Naz, and earlier we talked a little bit about how to avoid looking at the sun through a telescope, and I'll talk to you today about a way to safely and very expensively do it. So the little agenda today, I'll talk a little bit about myself and where I come from. I know some of you know me, but many of you don't. Talk a little bit about what is H-alpha, get to the technical nitty-gritty of what it is, it will be of interest to some of you. Then I'll talk about the hardware, the telescope, the camera, and the mouse that I use for my imaging. I'll also talk about the software that I use for capturing and processing all my images, and we'll take a look at a couple of images that I've taken over the years. And I'll do a really quick live demo session where I'm processing the last 2 steps of the sun, so I'll show you exactly how quickly I can get details out of the sun once you've had enough practice with it. And at the end, we'll all get together and vote whether or not I get kicked out of the club. So who am I? We've talked about who I am. Fun fact about my first name, Nazmus, is Arabic for star. My parents aren't particularly into astronomy, so I kind of got lucky and I landed into this hobby. I got my first telescope in 2006. It was a Celestron 60 AZ, really bad refractor, but I took my first image of the moon through it and I was hooked on astrophotography. I didn't get my first telescope, my first real telescope, until 2012, which is a Nexstar 6 SE. I know at least one person here has one of these. I still have it, and it has seen many sessions of sidewalk astronomy. This is on my roof in New York City, in Queens. My parents still live there. It's 18 stories up, so I had a really nice 360 view of everything, but it was always really windy. So it wasn't always fun, but it was fun. And 2012 was also a really great time to get into astronomy, but with a telescope because it was the last Venus transit until 2117. So this is one of the images I took from that rooftop, between clouds. I have 2 pictures. And I got my LUN 40 in 2023. I ordered it in 2022, took many months to get to me. And this is one of the images that I took with it. You can see that the dots crossing is the ISS transiting. So this is a composite of, it took about half a second for the ISS to cross it, and I was able to capture the frames with my setup. So what is hydrogen alpha, and why is it so cool? I don't think I answered the second question, but you'll know why. So very specific, H alpha is a very specific wavelength of light. Specifically, it's 656.28 nanometers in air, and it moves up to 656.46 nanometers in a vacuum. And it is visible, and it appears to be very deep red, so we can actually look at it. And it's everywhere in the universe. So the nebula here is in H alpha. Any guesses on what this nebula is? It's pretty well known. Yes, Elephant's Trunk Nebula. And this is IC 1396. So this was taken with the nighttime hydrogen alpha filter. And the bandpass for a nighttime hydrogen alpha filter is around 3 nanometers, which is incredibly small, but it's still too wide for solar imaging. And so it is unsafe. But there are cool experiments you can do with a white light filter and a hydrogen alpha filter that I will go over in a few slides. And of course, the sun also emits in hydrogen alpha. The sun also emits other lights such as calcium K, pretty much every other part of the electromagnetic spectrum, but I'm mostly concerned about H alpha. Sun and hydrogen alpha. So a lot of people are familiar with white light imaging, where we take images of the photosphere, and the photosphere is so bright and so overwhelming that it eats up any hydrogen alpha that actually comes through to us. So we need special equipment in order to separate the H alpha wavelength to let us see and image them. And what we're most interested in is the chromosphere light, and we can really easily see it when there are prominences during solar eclipses. So this is from the last April solar eclipse, where we saw the chromosphere appearing in these bright red prominences. The moon is a great occulting disk. And with proper H alpha filter, we can see so many more details that we don't need the moon to block the sun. We can see prominences, we can see filaments. They're technically the same structure, it just depends on where on the sun they are. Prominences are on the limb, filaments are on the front. Sometimes they're called philochrons if they transition into the other. I have a cool time lapse of them that I'll show you. You can see sunspots, you can see something called solar spicules. They look on the very right-hand side. You can see like hairline structures. It's really hard to see with my small Lund telescope. But with the bigger telescope on the limb, you can see like shaggy structures on the limb of the sun, and those are the spicules. It's pretty interesting.
Now, is these images all taken with your 40?
Yes, yeah. These are all the images you'll see today are my own. To talk about the hardware, so the Lund, there are several brands of dedicated solar telescopes that you can buy. Lund is probably the most, maybe the most well-known, right behind Coronado. As we know, Coronado may be going out of business. But I saw them being sold at Costco recently for around $400. I hope there's a manual that comes with it. And very recently, Skywatcher announced the Heliostar. It hasn't been released yet, but competition I think is good for consumers, especially if Coronado's going away. I have no other opinion of it besides knowing that it's coming. And there's also the Solar Scout, it's by Daystar. Other piece of hardware you can use is something called the H alpha eyepiece. Daystar Quark makes these. They replace pretty much your eyepiece, and you can look through them. They're electronic, and you can turn any f4 to f8 refractor into a hydrogen alpha telescope, which is pretty cool. And their price range differs based on which one you get. I don't really have any experience with this, so I won't be talking about this. Everything I'll be talking about is with Lund. So the parts of the hydrogen alpha telescope. So this is where the magic happens, that's how we're able to see hydrogen alpha. So the Etalon is not specific to hydrogen alpha telescopes. It's used in laser interferometry quite often, and it's an optical interference filter used for wavelength tuning. And in this case, we're tuning for the 656 nanometer wavelength. And the top two pictures are of my Lund. There's two ways to tune the wavelength on the Lund. One is with a tilt tuning, which is, you can see I tune the wheel, and it physically makes a gap or tilts the Etalon within itself so that the light bends a certain way in order to let me see the proper wavelength. The other way is pressure tuning. So this increases or decreases the air pressure within the Etalon, and that changes the refractive index of the air within the telescope, and it has a similar effect to just tilting the glass so that light bends a certain way. And I already went over the range of the hydrogen alpha wavelength, and that's what we're trying to get into. So the tuning will shift the light one way or the other, depending on where you are. And I thought this was a really nice diagram that was created by David Yozel on cloudy nights that shows how an etalon really works. So an etalon is two reflective, precisely spaced, extremely flat parallel surfaces. It lets in light, it bounces around quite a lot, and then only one wavelength of light gets through. And we can see by the top chart here that sometimes we get extra wavelength that we don't want. So what the lunch does is it has something extra called the blocking filter, and this filter is tuned to only allow the wavelength of light that we want. So along with the etalon and the blocking filter, we're only able to see just that wavelength. So we can eliminate every other piece of wavelength that we see. And the wavelengths in hydrogen alpha telescopes are measured in angstroms. 1 angstrom is 0.1 nanometers, and that explains why 3 nanometer, although small, nighttime hydrogen alpha filters are still too wide for H alpha imaging of the sun. A lot of etalons that we find in the market are between 0.5 and 0.7 angstroms, some are 1 angstroms, and you can stack them and you get dimmer and dimmer, or a narrower wavelength of light, and when you start getting to 0.3 angstroms, it starts getting dim. So when you're looking visually, it's harder to see, but with the camera there, it's much easier to bring the details out. Bob Yozel, so sorry, the last image was credited to David Knisley. Next one is Bob Yozel. He created this chart to show how stacking the etalons will change.
Sorry, somebody's popping stuff out.
Yeah, so you can stack the etalons in order to get finer and finer details. You can go from single stack to all the way to quadruple stacking 0.7 angstrom etalons, and you'll end up getting 0.3 angstroms of light going through. So that decreases the light, but it increases the contrast and the details you'll be able to see from the surface of the sun. I use a single stack. More stacks you have, the etalon is the most expensive part of the hydrogen alpha telescope, and the 40 millimeters is quite small, and it's cheap, and it's still very expensive. Continuing to talk about the etalon, this is another really nice example created by Bob Yozel that shows why the etalon is magic. So if you look at the top left panel here, so imagine we're looking at the sun with no filter, this is what we see. On the second panel on the bottom left, we have the white light filter with we have white light filter. So it's basically looking at the sun just really dimmed down. On the top right, we have the three, you can't really see it on this one, but it appears redder. It's like the second panel, but it's redder. I think it's the projector. And that's the experiments that you can do. You can put a H alpha nighttime filter underneath the white light filter. You can see some structures, not like an H alpha filter, not like an H alpha telescope, but it's still pretty cool. The thread I linked to over there, I can post it on the forums later. Some people have done the experiment, they've posted their results there, which is really interesting to look at. And the fourth panel, this is with an etalon. So what the etalon does is it eliminates every other piece of light from the photosphere, and all we're able to see is the H alpha light represented by the candle light. So the etalon is kind of magical. And then everything else, I already briefly talked about the blocking filter. It's mostly for safety. It removes any more unwanted wavelengths of light, and it usually comes in a diagonal or straight through format. An energy rejection filter is pretty much like a UV IR cut filter that decreases the harmful rays that will get through, usually with eyepiece H alpha hardware. Other parts of the hydrogen alpha imaging setup is the mount. I won't spend too much time on this because I know a lot of you already know what all of these are. We have an alt-as mount. It's easier to use, but I like taking time lapses, and one of the things I always have to deal with is field rotation because the Earth rotates. And of course, we have the equatorial mount. It's a lot harder to set up, especially during the daytime, if you don't have a permanent setup, because getting polar aligned during the day can be difficult. They're usually heavier, but they're excellent for time lapses. So whenever I go out doing solar imaging, I have to decide whether I want to do a time lapse or not. If I want to do a time lapse, I'll take an equatorial mount. We can post-process the field rotation out, but it's much harder to do. So I would rather not deal with it. That's why we buy multitudes of gear to eliminate problems. The next part is the camera. So any camera will do. It doesn't have to be anything special. And I have examples. So this one was taken with a cell phone. It's not anything special, but you can see, the projector is killing me, but you can see some prominences, some sunspots, there's a couple of filaments. And the reason there's glow here is because I used a cell phone mount, and it doesn't go flush against the eyepiece. At night it's fine, it's dark, but during the daytime the sun is just everywhere. But this is a really good representation of what the sun would look like if you're looking through the eyepiece of hiding off the telescope. It's very red, but it's visible, the structures are there. With the LUM 40 at 12.5 millimeter eyepiece, I find it's perfect, it fits the field of view, and I can see quite a good amount of detail. You can also use a DSLR or a one-shot color camera. It looks a little bit better, you can see more detail. The prominences are there, you can see some filaments, some sunspots. The only problem with one-shot color cameras is that you only end up using a quarter of the pixels because the green and blue pixels are not used because the wavelength is all the way on the right-hand side of the electromagnetic spectrum. But it's possible to do. The best camera type to use is a monochrome astrocam. And with that, from the get-go, you get so much more detail just by turning it on. You don't have to worry about decreases in resolution, the contrast looks better, and it just works. And what I use is a QHY 53178M guide cam. It's a really small camera. Like I said, it's a guide camera that is doubling as my solar camera. So I save some money that way. A couple things to note about installing the camera is that there's another type of interference pattern that happens, it's called Newton's rings. It happens when light reflects off a curved surface, such as with a telescope, and a flat surface, like the flat camera sensor. And we get these concentric circles that appear on the ring. And this is what it kind of looks like. You kind of see it looks kind of cool. You're like, hey, there's waves on the sun. And then, it looks cool for 5 seconds, and you're like, wait, that's kind of annoying. How do I get rid of it? So the way I get rid of it, or the way you're supposed to get rid of it, is to add a little bit of tilt so that there's no light bouncing and creating an interference pattern. A lot of cameras have accessories for tilt adjustments, so you can buy one of those. A lot of newer planetary cameras are coming with built-in tilt adjusters. I didn't want to spend any money, so what I do is I take my camera, I kind of force it into a diagonal, but not much, and then I only tighten one of the thumb screws. That works. I just need a little bit of tilt. Any way to save money in this hobby. And then when you take the picture, the Newton's rings are gone. And just so we're on the same page, the Newton I'm talking about is Isaac, not the other one you may be thinking about. Goes by the name of Fig. I have a couple more jokes. Alright, so we're going to talk about software now. On how I capture and process these solar images. The two mainstream software that you'll use for capturing any kind of solar system images is Firecapture or SharpCap. I've been using Firecapture for a very long time for planetary, and it translates really well into solar imaging. There are already presets for hydrogen, solar alpha, so I didn't have, the first time I turned this on, I barely had to figure out what exposures I needed, what gain I needed. It was just all there. And with my monochrome camera, the sun already looks really great. You can also do lucky imaging with the plugin in Nina. I haven't tested that yet, but other options are available. And for anyone that doesn't know, lucky imaging is just taking videos where we try to get as many frames as quickly as possible in order to get lucky with the light coming from our object through the atmosphere and hitting our sensor perfectly. We assume if we take thousands of pictures, at least a few of them will be good. One of the things that we need to do with a lot of astrophotography is to remove dust specks. As much as we don't want dust getting into our imaging train, they still get there. So I use for nighttime imaging, you'll use like a flat panel, you'll take sky flats or something. And for my solar imaging, I use a high-tech solution called a translucent plastic bag. It works really well. The idea is to just flatten out the light you're getting from the sun so that you can see the dust. And fire capture or sharp cap will eliminate those dust as you're taking images, so you do this beforehand, so you don't have to do this after. And looking at a couple of examples, so if I go back here, you can see like a little dust up here, and then after the flat frame, the dust is gone. And looking at it before and after, what it looks like with the plastic bag on, you can see the dust kind of goes away. There's a gradient, it also gets removed. It takes a minute to do, and it just makes the images look a lot better. Nowadays, I have a 3D printed cover with a milk carton cutout that diffuses light a little bit better, but that plastic bag goes with me everywhere I take my lunch. Lucky Imaging, these are the settings that I use for my lunch. You can see that this is actually a video that's playing here. So this is actually a Lucky Image video. This was one of the better seen days where the sun actually looked pretty nice. And you would want to take images in RAW format like .ser, RAW AVI. Fire capture also lets you save in FITS files, PNGs. And I do between 1,000 and 2,000 frames per video. Because I like doing time lapses, I'll take like hundreds of them. A couple of challenges that I usually come up with is focusing and tuning. So my Lunt 40 has a helical focuser. You can upgrade to a feather light focuser, which has fine focusing for money, which I didn't want to do. Or you can buy your own aftermarket focuser for money. But I figured one day I want to upgrade to a bigger solar telescope, so I'll put that money towards that. So focusing is always a problem, but it's not too bad. I'll suffer the helical focuser. The sun is also very bright, and no matter how hard I try to hide my face from the sun, it's sometimes really hard to see the screen, like on a computer screen. And so like tuning gets difficult. Like the sun, you're like, am I there? Do I have to turn the wheel a little bit more? It's like, I probably spend most of my time just focusing and tuning than actually imaging. Because when I start imaging, I turn it on, I go inside, I come back and check later. And alt-F field rotation, I already talked about time lapses. Time lapses, cool. Stacking and post-processing. So there are a few types of applications that you can use to help you post-process. And I'll actually live demo a couple of them after I'm done with this presentation. The first one is PIP. So PIP stands for Planetary Imaging Preprocessor. It's currently defunct, but you can still find it. The person who made it just let the website expire, but the executable is still online. And it's great for centering the object, debearing, cropping, and a couple of other options that are in there. I don't use it as much because the next app I use is AutoStacker. So AutoStacker 3 was around for about 10 years, and then AutoStacker 4 came out at the end of 2023 in beta, and that actually does a really nice job of centering the object so that I don't even have to go to PIP. So I'm thankful for that. AutoStacker 4 also analyzes each of the frames of my video, so I know how good my frames were. So in this video, you can see that anything after like the halfway line here, like I won't use them. So I ended up using just stacking just 5% of the frames, so that's what AutoStacker lets me do. And it's super fast now, much faster than AutoStacker 3 was. Another app that has come out recently is AstroSurface. I've been using it quite a lot for planetary imaging. I used it a little bit for solar, H-alpha solar editing. I don't use it as much, but it came out as like an all-in-one solution where it replaces PIP, AutoStacker, and Registax. And it does a really nice job of it. It's free. Next app is called IMPPG. This is used for tone curves adjustments and sharpening. This literally only has 2 functions, and it does those 2 functions really well. You can see an example behind the tone curve of how good the sun looks. These are the exact same frames of the Lucky Imaging video that was playing a couple of frames ago. It just looks like so much more detail. And then for colorizing I think is more like an artist pejorative, like you decide whether you or not you want to color it. And you can use GIMP or Photoshop. There are other tools out there. GIMP is free, Photoshop is not. And I try to stick with free applications when I do stacking and processing, just because it's more accessible to more people. Just looking at my setup before I do my live demo. So on the left side, you have my SolarQuest mount, which I will do for like really quick. It takes me 3 minutes to get running. I have my Lunt 40, my camera on, you can see the shadow of my son and me, and then fire capture running on that laptop. And then I have my high-tech flat panel in this image here. Sometimes I will do both H-alpha and white light imaging at the same time. So that's my 6SE. This was during the October 2023 partial solar eclipse that we could see from Boston. From all the shadow, you can see that there were clouds. So nice setup anyway. You don't know, sometimes you get lucky. So now I will do a quick demo. So I'll quickly process this video here. So this is a lucky image session of the sun taken, what is the date? September 5th, 2024, it's a few months ago. So this is what the lucky image looks like. This is out of, when I'm looking at fire capture, this is what the sun looks like. Looks pretty nice here. We can see quite a bit of feature. You can see some prominences, not on the projector, but on my screen. And I'm going to skip the auto stacker piece because sometimes analyzing and stacking can take a little while, so I don't want to have you sit through that. But this is what it looks like stacked. Right, so I took the best 20% of the frames. It's a 500 frames video, so about 100 frames were stacked. And we can see quite a bit of detail around the sun. It looks a lot sharper than the video did because I picked just the best frames. We can't quite see the prominences, but I promise you they're there. And the next step, we will bring it out. So next step is I'm going to open ATMoB, and I'll open that file there. Try issues. Okay. And like I said, ATMoB does two things, and it does them very well. So the first thing is tone curve adjustment. And this is just, so the way to look at this is that it starts from like the inside of the sun and then goes outwards. And we're trying to edit the brightness at the different levels. And if I start making changes, so you can see that like different parts of the sun get dimmer and darker. You can see the prominences start to come out, right? I'm going to reset this. And I like working with an inverted image. So where the sunspots are now looking dark and the filaments are looking white instead of dark. And it just looks a little bit better, I think. So it takes a little bit of time, but I can spend hours on this, and we don't have that much time. So I'm just going to do a really quick one and show you that once you have a setting done, let's say I spent 30 minutes on this, and this looks good. It doesn't, but pretend that this looks good. I did some sharpening, it does some loosely Richardson deconvolution, which is just a way of saying sharpening. It's a special algorithm. It also does unsharp masking. You can save your settings so that the next time you turn this on, you don't have to spend hours trying to figure out what you did last time. So that's what I'm going to do. I'm going to load a setting that I spent hours on trying to perfect, and I'll open that. And then now this is what the sun looks like. So imagine I spent hours to get that tone curve, and this is what the sun looks like. Projector is making it look darker, but it looks pretty good on my screen. And now we can see, prominences. We can see filaments. It looks kind of really nice. And then once you have your settings, like the processing gets faster and faster because you're used to it. You have your saved processes saved. They can just apply over and over again. And with applications like ATMoB and GIMP, you can do batch processing, especially when you're doing time lapses. Is really helpful because you put in all of your images at once, and it pops out a beautiful 100 frames of things that you've turned to time lapse, which I'll actually show an example of.
Any way to batch process AutoStacker, or is that all?
Yes, you can batch process PIP, AutoStacker, AstroSurface, ATMoB, GIMP, Photoshop. I look for the easiest ways to do things. Otherwise, I don't think we'll be doing time lapses. So I'll just save this. Process.
Question.
Yes.
So the prominences on the surface look almost 3D. How did you get that effect?
It's at the tone curve. So it's working with. I just figure out like where let me step back a little bit. So like I said, like the tone curve starts from the center of the sun. In this case, it's on the right-hand side because I inverted it, and it goes out to the outside. So it's just like trying to figure out like what I edit, like where does it affect. So you can see that it's like, you know, when I'm making that edits, it's like this part of the sun that's getting affected. So it's a little bit of a, it takes a while, but I found these settings that work for me. You just have to play with the tone curve. And it does look 3D. It does look kind of cool.
Well, it's also negative, right?
Yeah, it's a negative, yeah. Yeah, but if I did it the other way, it's not gonna work now, but you see it still kind of looks 3D, but it's black. Let me just reset this and then it'll, there you go, so, look at the tone curve and then invert it. So you can see now, it still looks kind of 3D, but it's black now instead of white. So I think you're right, Sal, that the inversion makes it look, it gives it a bit more depth.
It's personal preference, 'cause
Yeah, but now I can't see the prominences.
yeah, I'm on the fence.
It's like magic. Look at that. Okay, so I saved this. Now I have this, right? So now I can colorize this. A lot of the times, I won't even colorize it because this looks really nice. I'll share the monochrome version. It looks fine. And when it comes to colorizing it, I'll open this in GIMP. Again, it's personal preference, like what color you want. I know we pick orange for the sun, even though the sun isn't orange, it's white. But I'm just quickly showing you just how quickly you can do this in GIMP is. So first I need to convert this from monochrome to RGB. And then we can go to the curves and we can adjust the red, green, and blue curves separately. And then like magic, the sun starts to change color. And the pink sun looks pretty good. But it's a little bit of playing around with the curves adjustments, figuring out like what works. And like the values here, like the input and the output, you can save them. You can save them as presets, which I don't have any in this on this computer. But you can speed this up as well. You can batch process all of them. So if you have 100 frames, you just need to do work once, really. That's okay. And now I can export this. Now I have the 3 versions, right? So I have, this is stacked out of AutoStacker, this is with IMPPG, and this is with GIMP colorization. So
nice.
So I do have, so as I was talking about, there's a way to batch process them, and then you can end up getting really nice time lapses. So let me play this really quickly. It's kind of hard to see all the stuff that's happening while it's zoomed out, but I do zoom in this at some point.
Nice.
You kind of see, so you can see at the bottom, this, the projector's really killing the vibe.
Yeah, this is
much nicer.
Yeah, so you can see lots of activity.
40 millimeter?
This is 40 millimeter. You can see there's a solar flare there, and if you look at it on the other monitors, in negative, it looks a little bit better. It throws up a prominence and then rains down. So this is about a 40-minute time lapse. It's pretty quick. Sun moves slowly, but it also moves quickly sometimes. Here's the monochrome version of it. People on Zoom are probably getting a better view than the people in this room.
So Naz.
Yeah.
So when you're doing these time lapses, are they like, do you use like an interval timer to get like a minute's worth of video and then do your best, lucky imaging on that minute, and then, at maybe 5 minutes later, do another 1 minute, et cetera, to collect all the data for the time lapse?
Yeah, that's a good question. I just skipped over that step. So in Fire Capture, there's an auto run feature where you can set an interval there. So I'll say, every minute take 1,000 frames. So it's all in Fire Capture. I don't need to use any kind of intervalometer. It's just all there. And I'll tell it how many frames to take, which I usually set 99999. Because I set it, I go inside and I come back out later. And if I'm using an equatorial mount that's tracking, I guarantee that the sun will still be in view. And even if it moves a little bit, it's pretty good. Like, I've done this long enough that I'm pretty confident in my setup, as I say. And
Thanks.
yeah, no problem. And then finally, I'll quickly go over some of the images that I've taken over the years. So here's one image. You can see I have giant prominence over there. We already saw this one with the Newton strings. Here's one. This is before I started using IPPG. So there are prominences around, and I just had no idea how to take it out. So it took a while of learning. Here's another nice one. Lots of great prominences around the sun. This one's a cool one. It's like twisters coming out. I do have a lot of frames of this, but I use my Solar Quest, so I have a lot of field rotation that it's just a pain to work out, so I didn't actually turn this into a time lapse. This was of the October 2023 solar eclipse, so I did get 30 seconds of a break in the clouds. So some doesn't look great, but this was my only H-alpha image through it. This one I thought looked really cool, because there's a really nice prominence on top. It's like a dancing alien type of person. And here's another one where I flew to the other side of the sun to take this picture. You can see it's just how small it is compared to the prominence. And we're back to the beginning. Yeah, any questions? Yeah.
Talk about the difference in tuning surface features versus prominences.
When it comes to the Daystar quarks, they have two versions. They have a prominence and a chrominance version, and they let you see the different things. But when it comes to tuning the lunt, I just try to get the surface, and I learned that once I get the surface, the camera and my setup is sensitive enough that the prominences will be there, and they come out when I invert the image. Like a couple of frames ago, like this one, like the prominences are there. Like if I were to go back and redo this and invert the image in IPPG, I'm sure I'll be able to get the prominences out. So now my goal is to just get the surface, and I know the lump will pick up the prominences.
Because visually there are differences.
Yeah.
So,
Yeah. It was visually speaking, some of the brighter, exactly. Yeah. Like when I usually look through an eyepiece first before I plug in a camera, just because it's really nice to look at. Like the thicker prominences, they're really easy to see visually. Like the thinner ones, yeah, like the thinner ones, like the one up here on the top right, I don't think I was able to see that visually. It was just like thin enough. So like sometimes the camera surprises me. Like I'll take a picture and it's like, oh wait, there's something there. Just do that. Yes.
How much do your IMPPG curves vary from image to image? Does it look roughly the same, or are you varying it quite a lot?
A great question. So last time I edited this was in, I have the date here, September 6th. So I very infrequently have to vary this because my imaging train stays the same. Mm-hmm. The results I get is mostly similar because the exposure settings I use, they're also very similar. I don't really have to worry about the curves adjustments. The only time I have to worry about that is like if I'm shooting like thin clouds, then I have to adjust my exposures in order to try and get the detail. So I'll make some adjustments, but usually not. Like once I figured it out, I've just been making modifications, like very small modifications to the same IMPPG preference file for the last couple of years.
It is kind of the same target, so with the same optics, I think. I mean, it's not like as nighttime photography. From target to target, you have to change the curves and stuff. So.
Yeah.
Yeah, I think part of this though is single stack, because in double stack, that's not really true anymore because you have too many variables.
Right.
But I'm very amazed by this. I'm amazed by two things. I've been using this for years, and I never thought of doing the inverted image, and I never thought of highly nonlinear curves.
Yeah.
And these look wonderful with just one set of exposures. There is no matter of taking a separate exposure of the external prominences versus the internals, and I really like it.
Yeah, I always try to do the laziest path.
Yeah, I sometimes take my double stack off. I sometimes go single stack, it's just easier to.
Oh, cool. Yeah. One day I'll get a bigger lunch with a double stack. I have more money. That's always about the money. Sorry.
Question from the crowd.
Yes.
Can you talk a little bit more? Oh, Mark Helton here. Can you talk a little bit more about the Etalon tuner? You have a focuser, but I understand I kind of understand how it works because I've had some long talks with the folks at Lunt. But can you explain how that works when you're focusing? How you actually are using the tuner as well as the focuser to get the image where you want it? Maybe that's not the right way to ask the question, but
Yeah. So, well, the tuner for me is. So my first goal when I start imaging is try to get focus, and I use the lunar limb to try to make sure the lunar limb is in focus. If that's in focus, then I know my sun is in focus. I don't even worry about tuning until I'm 100% certain that I'm focused. So I do focusing first, and I know the pressure-tuned systems, it's really close to the focuser, but I think if I had a pressure tune, it would be the same thing. I would try and focus first on the lunar limb, make sure it looks like a disc and not a blurry blob, and then try and do the tuning. Does that kind of make sense? I don't know if I answered your question.
I guess I'm still not exactly sure what the tuner you're trying to tune the frequency of the H alpha.
Yeah.
Better. You're trying to. Okay, and I guess that's kind of just watching and seeing how it affects the image.
Right, yeah, exactly, yeah. Like Corey's saying, I try to go for a contrast. So I'll zoom in. If I can find a filament in front, I'll zoom into that, and then try and get contrast in it. I'll also go into the center because you can be off band even if even if it looks good, it can still be a little bit off. So it can take a little bit of adjusting in and out. Yeah.
I just wanted to, Mark, have you looked through a hydrogen alpha telescope with your own eyes?
I've never had the chance. No, I'd like to sometime.
Yeah, when you get a chance, come to the clubhouse on a sunny work party. Okay?
All right.
You have tons of them out there. And when you actually look through it and try it out, it'll make much more sense.
Okay, that's what I figured. All right, thank you. Very good talk. Appreciate it.
Just from Mark Helton's, the sun, the H alpha is very, very specific, and the frequency will vary depending on whether the sun is straight up 45 degrees from the horizon or on the horizon. And that's why you got to tune it. There's no set frequency because the frequency changes depending on where the sun is in the sky.
So it's similar to polarizer almost.
It's not polarized light, but it's just it's very specific for the frequency, and the frequency is altered by multiple factors, including the height of the sun from the horizon.
Okay, thank you.
Does changing the tuning ever change the focus at all because the wavelength is slightly different?
No, it's not enough. Like it's like a fraction of a nanometer that we're tuning. So it doesn't change enough. But that would be probably a little bit annoying to do that.
Can I ask a question?
Yes.
So I've learned something. I never thought of using the inverse. I'm going to try that next time, see how it works. But after I do IMPPG, I usually use NAFE, N-A-F-E. It was produced by NASA for fine-tuning their imaging of the sun. And I find it useful. I don't know if you've used that, but okay, you might want to try it. It's freeware. I start with AutoStacker, then go to IMPPG, then go to NAFE, and then I colorize it in PIX, which is just a minor procedure at that point. But you might want to look at NAFE. NAFE, I find it adds a little more sharpness, and it just adds more to the image from IMPPG. Try it out, see if you like it.
Thank you, Mario. So, yes.
Earlier in the evening, we heard about the proximity of Venus to the sun. Could you use this system to train it on Venus in order to have enough HL?
Not enough light. So we're getting like half an angstrom of data of light, which is not enough for anything other than the sun. Yes.
Are you using 8-bit or 16-bit? Well, which I know is not true, 16-bit with fire capture. But are you using the highest bit?
No, I can just use 8. Yeah, doesn't matter too much. Just 8.
When we do 1 micron Venus imaging of the surface, we tend to do some very exotic stretches, non-linear curves and like that. And we find that the image actually will withstand more of that aggressive processing if it's captured in 16.
Yeah,
especially when we're only capturing a few thousand frames.
Yeah.
With planetary, I'll go 20 to 40,000 frames sometimes, those things capture.
Yeah.
But with this, I think you said 2,000 is typical.
Yeah, 2000. Yeah, usually because I try to do time lapses. I can do more if I wanted to. The camera I'm using, I think it maxes out at 12 bits, so I can't do 16 bits if I wanted to.
Yeah, it doesn't. It never. Even though you set fire capture at 16, there's a lot.
It's still, yeah. Yeah.
Does these sensor size or the pixel sizes that matter?
I think with like any kind of imaging, it will matter.
You can hit that like 40 millimeters to what was the
400, so it's an F10. Yeah, so you'll run into like sampling concerns here and there. So this camera I'm using is 2.4 micron, so it's pretty small where I can get finer details. But I could probably do better. I know there's a 2 micron camera out there that probably give me better detail, but this is a small telescope. I think if I want like finer details, I need a bigger telescope, bigger lens for better resolution.
Dual-purpose camera for guiding too.
Exactly.
Trade-offs.
Exactly. Yeah.
Real quick question. You don't mess with the orientation at all, so you're just using natural orientation.
Yeah. I mean, I've used WinJupos to try and sometimes, like if I try to be accurate, I'm going to share it online because I know some people really care about the orientation. I don't most of the time. Any other questions? Thank you.
Thank you, Naz. Thank you. I think we have reached that part of the time, so next monthly meeting is February 13th, 8 p.m. See you all there. Thank you.